Hi, and welcome back to Waveform Science. I'm Jeff Hagan. Behind me, we have two Bluetti devices that we have previously previewed. We have the AC180T and the Multicooler. We took a look at these on the week of CES, interestingly the day after the box arrived when I hadn't even opened it yet. We did an unboxing video just to kind of take a look at them. Since then, I've actually had enough time to do some pretty serious testing. And today we're going to focus very specifically on the Multicooler. Because between the AC180T and the Multicooler, there seems to be much more interest in the Multicooler itself. So we're going to go into that in detail in the next hour or so. As always, I am not paid to make these videos, but they did send me the units because they're not out yet. Otherwise, how would I get them? So these are prototype units. They are pre-release units, and they were provided at no cost for the make of the video. Not entirely sure if I get to keep these ones or not. Bluetti will let me know afterwards, I guess. Bluetti has no control on the video here, so they can't tell me what I'm going to say or whatnot, and I wouldn't let them do that anyway. So despite them providing the unit, this is going to be as unbiased of a review as I can. First off, we're going to start with the fact that this is not the first refrigerator they have shipped. The first one that they've shipped actually is this guy, which was the prize for the live streams. I'm 99% sure they don't make this. I think they just stamp their name on it and somebody else makes it. But that being said, they have looked at refrigerators in the past to the point where they've ordered some and stuck their name on it. So what does the refrigerator actually do? This is a single zone refrigerator. In other words, it does have a compressor in it. It's got one zone. That zone can either be set to refrigeration mode or freezer mode. It cannot do both refrigerator and freezer. And as a secondary function, it has a ice maker compartment where it can make ice. The ice maker compartment, as it is a single zone fridge, does not work as a freezer. So similar to a tabletop ice maker, it's going to make some ice. And then if you just let it sit for a while, the ice will eventually melt. But it does stay cold for quite a while in there. So it kind of does the job. We'll take a good look at it over the next probably an hour. And let's see how it behaves. How much does the Multicooler weigh? Both my scale and Bluetti agree. 52.9 pounds here. Now 52.8 pounds. I guess my cord is stuck in the bottom of it there. Change the weight a little bit. But right around 52.9 pounds is what they say. Now in order to get this weight, there is no battery in it. So this is empty. There's no tray in it, which we'll see in the accessories in a minute. The ice maker tray has been removed, so there's nothing in there. And the metal trays have been removed from the main compartment. So basically their weight is the Multicooler itself stripped with nothing attached to it. External dimensions of the Multicooler. We are looking at a little bit less than 28-ish on this dimension. On the depth, we're looking at about 15, and the height, we're looking at about 19. That's all the way to the floor, by the way. So we're including a little wheel here in that measurement. Manufacturer says 28 by 16.5 by 18.7, and they specify their measurements are without the wheel or the bar on the front. Internal dimensions for the Multicooler. Bluetti advertises the Multicooler as having a 42 quart or 40 liter refrigeration compartment on their Indiegogo page. 50 quarts total, 55 liters is what they advertise. Is it that size? This is really difficult to get on camera because I'd have to be measuring the inside of the device. So instead, we're going to jump to a 3D modeling program. These two blocks right here are the refrigeration compartment itself. This block down here is the battery compartment, and this block over here is the ice maker. And I did put these into scale according to the measurements that Bluetti gave me. These over here, these little measurements, these are in millimeters. But yeah, we're going to do things in inches because most of my viewers are in the US anyway. So the left one, we got 12.8 by 7.7 by 14.7 inches. The 14 is tall, by the way. This one over here is 12.8 by 7.8 by 9.3, and yes, I did sort of confirm these with a measuring tape, just it doesn't show up on camera well. I can't stuff the camera down inside the fridge. The battery compartment itself, if you look at this from the top or the bottom, you'll see the battery compartment's actually a little bit wider, not a lot wider, but a little bit wider than the food compartment. That's because the food compartment between the inside edge of the food compartment and the outside of the refrigerator has insulation. The battery compartment does not have insulation. You don't really want to put food in there. The size of that for the battery compartment is 5.9 by 4.9 by 13.5 inches, 13.5 being, of course, this way. And this is what it is in millimeters up here. And then the ice maker over here, we are looking at 8.5 by 6.4 by 9.9 inches. So how does that work out into, because they don't advertise inches, they advertise quarts or liters. So how do we do that math? So the ice making, excuse me, the total storage area of the food compartment, that's this one plus this one, works out to, after you do the math, about 2,400 cubic inches. You basically multiply them out. And I'm going to turn that into quarts here. So 24 cubic inches turns into 41 quarts. Right there, that's the refrigeration compartment. Bluetti advertises the refrigeration compartment as being 42 quarts. My math says 41.6. It's closer to 42 than it is to 41. If you're going to advertise it in whole numbers, I don't see really a problem with that. It's a little smaller than they advertise, but not that much. They advertise the ice making compartment as being 9.5 quarts or 9 liters. For the ice maker, this is what it turns out to, 9.47. Again, rounding error, so no problem there. And you advertise the two together, multiply them out and turn it into liters. You get 51 quarts total to add up the ice compartment and the cooling compartment. They advertise in quarts as 50, so no problem there. And 48 liters, they advertise as 55 liters, which is a little strange. So either my converter is wrong, or their advertising is wrong, or there's some unit conversion there. That's a little strange. But it is a little bit smaller than they advertise. Not that much smaller, kind of within the noise, and definitely within the norms for other coolers in the industry. The multi-cooler can be ordered either with or without one of these B70 batteries. The battery itself has a button on the front, which gives you 5 LEDs for showing you how charged it is. Has a little control that releases a clasp that holds the battery in. On the back of the battery, we have the connectors and a vent on the back. The battery itself weighs in at 18.85 pounds. This is pure battery all the way through, so it is really heavy all the way through. Hefty battery. The manufacturer says 18.7 pounds. My scale says 18.9 now, so pretty much about the same measurements. The dimensions, we're looking at a little over 13 inches this way. 7 inches and about 5 or so on the depth. Bluetti says 5.3 by 6.3 by 13.8, basically the same that I measured. So that's the battery itself, and you can get the cooler either with or without the battery, and of course we are going to test both. What do you get along with the cooler? Excluding the battery, of course, cables and things. Laid out on the table here. First off, you have, of course, the instruction manual, paper manual. You've got a interesting cable. You've got MC4s on one side and the pretty standard refrigerator connector on the other side of the same cable. This is how you'd recharge it from solar, and yes, we're going to show you using this cable a little later. Next up, you have the cigarette lighter cable. This will work from 12 volt or 24 volt vehicle, and it is, I think, about 10 feet long. Relatively good length, pretty standard cable for a fridge. We have a charging brick and the AC cord part that goes with it. This part over here is standard. The charging brick's output specs are 24 volts, just straight 24 volts, 6.35 amps. So this will recharge it, but there's no actual charger in here. This is simply giving you voltage. So that's actually pretty handy, because if you need to charge it off something else, say you have a 12 volt power supply, a 24 volt power supply, as long as you can get this connector on the end of it, the fridge is just expecting raw voltage. So that's real handy. There's, of course, a bunch of trays. There's the two trays, these two, that fit inside the fridge itself. A couple of baskets to hold your food. They are rubberized on the outside, so they're easy to clean, dishwasher safe. These are the fridge. It isn't, but the baskets are. So those are nice. We've got the ice maker tray. That's the next one, which comes with a little spoon. So you got a little spoon to pick up your ice with, and you have the tray itself that catches the ice. These are all, of course, found inside the fridge when you get the fridge. And you have this little odd basket. This basket ships inside the battery compartment and kind of gets stuck in the battery compartment. Let's take a look at that real quick. We're now looking at the battery compartment on the outside of the multi-cooler. Let's open this up. And this is the space where the battery would fit. But when you receive it from Bluetti, it has this compartment inside of it. And you can see we've got a hook on one side. We've just got a flat side on the other side. The hook has to go toward the back or it actually gets stuck. So put the hook in there, and then we just sort of slide that in there and close it up, and then you can close this little door, and you have a compartment inside, which I guess you put your cables and stuff in there if you don't have a battery. Now, you don't want to put food in here. You can actually see this real thin on the bottom here. There's no insulation on this compartment. This is not cooled because it wouldn't make any sense to cool this, because normally this is the battery compartment. You can also see this thing kind of gets stuck in there. So don't really fully understand this compartment and what it's used for, really, because also this thing doesn't really fit inside the fridge itself. It's a little bit too wide. So yeah, I mean, you get it. I don't know how useful it is, but it's in there. And this, of course, is where you'd put the battery. So let's actually put a battery in here, because that's going to make the rest of this testing much easier. So the battery itself, you've got Bluetti logo on the side, and you fit it in, and it's got a little latch, and if you can read it, it actually says Bluetti along the side here, and you want the Bluetti logo to be right side up when you push the battery in. And that gets the battery in there. And you can push the button if you want to. You don't have to. You can turn it on from the top. We'll look at that in a minute. Many of the controls are on the top, so we're going to use a top-down perspective for a lot of this. So the primary door has a latch on the bottom here, where you push up on the latch, and then you can open the door. Here's the latch working. And that seals it up. If you take the door and you put it at about a 45-degree angle, and you pull up, you can actually take the door off. No tools needed, which is actually really handy, because you take the door off, you flip it back around, and you just set it on top of the unit when it's in storage, just like this. Why would you want to do that? Well, portable refrigerators, and I've had one for years in my camper, they tend to get mold inside if they stay shut up while they're being stored. So you wind up with very strange concoctions that you put together to prevent the refrigerator from closing. In this one, you can just take the door off. Yay! So let's put this back on there. There we go. I got the door back on. Next, we've got the two baskets, which of course it ships with. One in there, and we'll put the other one in there. Two baskets in there. There we go. Now on the other side, we have the ice making compartment. That opens up. It has a similar lip here. And this, you guys can see, is semi-transparent plastic, just so you can kind of sort of see into the ice maker, which also, because it's only one piece of plastic and it's not two pieces of plastic with an air gap in between, this is not insulated. There's no cooling in the ice compartment. It's got an ice maker, but it does not have a compressor in there. So this area over here cannot be used as a freezer. You put the ice basket in. It just goes in there. It's got a little handle to pull it back out. And you've got a little spoon here that's got some slits on it. And the spoon slits fit into the little splits on the basket, and that will put the spoon in there so you have a place to put your spoon. We can close that back up. Looking at the multi-cooler from the side with the wheels on it, we have a strap here. This is actually used to tie down the multi-cooler. This metal bit right here is used as a tie-down point. So if you're in a off-road vehicle and you want to make sure the multi-cooler doesn't get away, There's one of these on one side and one on the other. You can use it as a tie-down point. And they do have a drawer system that they sell, which I don't have because I don't have a place to put it. My vehicle's already outfitted, so I don't have another place for another one. DC output here. We've got a USB-C port and a USB-A port. We'll test those in a minute. DC input. This says 12 to 24 volts, or PV input, 16 volts to 28 volts, 200 watts max. And of course, we're going to test that to see how that works. We also, of course, have a spec sheet here, and we've got the air gap that's used for the compressor, which means that when you do store this, by the way, this right here and this on the other side here, that's where the heat comes out of this unit. So you really don't want to have this or this covered up while it's running. So you kind of need a little bit of space around it. So if you are going to be putting it in a vehicle, do consider that. On the opposite side, we have one more tie-down point. We have the handle that's on the other side, and we have the bar, which is used to move it around. This gives you something to grab on, and the wheels are on the back side here. And those two work together in conjunction to make this a little bit more portable. We're now looking at the multi-cooler from the rear. In other words, now the door would fold open up toward us. And there's one important thing to note on this side, because as far as I could find, it's not called out in the instruction manual, at least not the version that I was sent. Right here is the drain plug for the ice maker. That drain plug is going to allow you to take the water that's in the ice maker compartment and let it drain out the bottom of the unit without having to pick it up and flip it upside down. This is a 50-pound plus container. I'm very happy to not have to pick it up and flip it upside down. There is a second drain plug in the multi-cooler in the bottom of the food compartment, right there. As far as I can tell, by the way, that uses the same drain plug connector that every other portable fridge I've ever seen uses. Nice to have compatibility there. And that's if you get liquid inside the refrigerator. Now, the refrigerator itself is not designed for submersion. So when you clean these, you want to use a wet rag and wipe them off. You don't want to just take a hose and fill it up with water to let it soak, because it's not really designed for that. But in case you have something spill, like, say, for example, vinegar from pickles, and you don't want all of the rest of your food to smell like vinegar forever, there is a good way to clean these out, and that's very much appreciated and standard on most portable fridges. On-screen controls for the multi-cooler. How does it work to control it directly from the screen? So you have one button here, and that's it. Everything else is a touch sensor, so this is a physical button. To turn it on, you will press and hold the button. The light turns on. There we go. Now we're on. When it's in this mode, you can see the battery icon, the battery percentage, a guess of how long it will last, 25.5 hours in this case, whether or not Bluetooth is on or off, whether or not it's in eco or max mode, and the set temperature. So let's see how we change the temperature. So the maximum temperature you can set it to is 68 degrees. That's as high as it will let it go. How low can it go? You can set it down to -4 Fahrenheit. It's as low as it'll go. Now, if we want to change the other options, we can push and hold the gear button until it starts to blink. Right now, if I do plus or minus, it will change from Fahrenheit to Celsius. If I push this again, little on will blink. You can turn on and off Bluetooth. Not sure why you'd want to do that unless you want to make the app not be able to connect. You can set it from eco to max mode. We'll cover what that does in a bit. And then it goes back to Fahrenheit to Celsius. That's what those do. Now we have these two buttons as well. These are used for controlling the ice maker. And I don't have water in it right now, so we'll wait till we get to the ice maker section to actually cover how these two work. One more thing I missed in the previous segment. When it's running, the screen will look like this, and you'll just see a lock icon. To get the screen to come back on, you can either push the button, or actually easier so that you don't accidentally turn it off, press where the gear icon would be, which is right there. And then the screen will light back up again. It's still got the lock icon, which means you have to press the gear icon and hold it down to unlock it. Now you can actually change the settings. Next, let's take a look at Bluetti's mobile app. This is, of course, the same app they use for the solar generators, but because this isn't a solar generator, it's a refrigerator, the interface looks pretty different. So at the very top, we've got Multicooler F045D. That's just what I've named mine. That's the model number. Below that, we've got a Bluetooth icon. Says we're connected by Bluetooth. There is no Wi-Fi on this, only Bluetooth. We've got the battery percentage, 67%, same as what it says on the screen here. We've got a time remaining, 15.7 hours, which is interesting because they show that on the cooler, but they don't show that on any of the solar generators. I actually really wish they did show it on the solar generators as well. Next, we got a voltage, 26.4 volts. That's not on this screen anywhere, but is in the app. The voltage is interesting because there's no power plugged into it right now. So I'm guessing that's the voltage coming off the battery. Below that, we've got a temperature readout. That's the current temperature that it believes the inside of its cooling compartment to be. And then we have a setting, a slider, for us to change the cooling setting. So let's turn it down to somewhere in the refrigerator zone. There we go. That's a little cool for a refrigerator, but it'll work. So now we can hear the compressor kicking on. Below that, we have controls for the ice maker. So let's turn that on. And I do have water in here, by the way. Don't turn on the ice maker when it's empty. And we're going to show you what this actually looks like a little bit later. The camera and the door for the ice maker don't quite line up here. But it pops up, and we've got ice making turned on. And we've got some options. So if I tap on this option down here, I can make single ice or continuous ice. Single ice just does one ice run and then stops. Continuous ice keeps making ice over and over and over again until it runs out of water. Ice size, there's small and large ice. And we'll go into what that means in a little bit. Let me turn this back off. And yes, you can cancel it. The 24 pieces here, this is its guess of how much ice it thinks is in the cooler. It doesn't really know when you take ice out of it, though, so it's not very accurate. Self-clean mode. What that's going to do is it runs the water pump in the ice-making compartment to move the water around, but doesn't turn on the compressor. So it just runs the water around, and it does reverse the little tines, and I think that tines get warmer while this is running. So that's for cleaning purposes. That being said, I don't recommend putting soap in there. That's probably not a good idea because then you're going to get soap in your pump. So I would just use water. But that's just in case you need to clean it out every now and then. And, you don't really want old water stuck in the tubes. So it's a good idea to drain it out and clean it every now and then. But if you turn it on, you hear the motor starts to go. And it's just running the water. That's all it's doing. Just run the water. So we can also cancel that. Turn it back off. There we go. Now we've got the gear icon up here. We can share the device with others. This is used for if you have the fridge yourself paired with your app and you want to let somebody else use it, where later you can revoke access. So that's useful. Homepage display says whether or not it shows up on the homepage of your Bluetti application. Temperature, you can set Fahrenheit or Celsius, just like the main app. You can set refrigeration, can be either Eco or Max. Auto sleep, this is an interesting one. So what auto sleep does on the solar generator side of things is it changes the timeout of the screen. What it does on the cooler, turn the screen back on here, as far as I can tell, is nothing. You can take auto sleep and you can set it to, say, 5 minutes. Now, it says 5 minutes, and then it changes back to 90 seconds, and it just doesn't do anything. Now, you can go over to never, and it says never, and then give it a second, it's going to switch back to 90 seconds. And I didn't actually touch the screen of my app here. It's just switching back. So this auto sleep function, at least on the review unit, does not appear to work. The child lock, what that does, if you were to turn it on, it does. Here, now it's on, and now the screen has locked. And if you turn it off, tap on that, and it won't actually let you turn it off. Similar to the auto sleep function. It doesn't seem to work. Oh, there we go. Now it finally worked. So it actually unlocks the screen here. They call that child lock. Then you can tap on About Device, and that will give you some specs. So the Bluetooth signal, the serial number, the amount of power that it uses at maximum, these noise level and all this other stuff. This is all just the specs straight off their website. This isn't actually reading anything from the device. And then, of course, you have the unbind button. If you decide to sell your multi-cooler in the future, make sure you unbind it first because it can only be bound to one account at a time, and only the account that bound it can unbind it. So that's the app for the multi-cooler. Last little bit on the Bluetti app. Yeah, there is no firmware upgrade version in there. So if they have a software bug, they don't actually have a way to fix it remotely on the multi-cooler, at least on this version of it. Maybe that'll happen in a later hardware rev, maybe not, I don't know. Bluetti has been hesitant to comment on it, but it does appear, at least in the test version, that there is no way to do a firmware update. Next, we're going to test the USB ports, the output ports on the side of the multi-cooler. Bluetti specifications say that these ports do not function when the battery is not installed. So, of course, we're going to test it both with and without the battery. The USB-C power delivery port does spec out as a 100-watt port on the meter. That's with the battery installed. And you can pull 100 watts out of it. The USB-A port is marked as a 5-volt, 3-amp port, but interestingly, and similar to some other Bluetti devices they've come out with recently, it actually specs out as a quick charge port. And very specifically, it specs out as a 20-watt quick charge port. So that is significantly above the actual rated advertised specifications. So if any Bluetti engineers are watching this, guys, you guys should really mark your device with what it can really do, because you're down rating your own device, because it can do more than you've marked it to. To further demonstrate that this is in fact a quick charge port, I'm going to show that it can do multi-voltage. Right now it's at 5 volts. There's 9 volts. There's 12 volts. And it doesn't want to go any higher than that. So it goes up to 12 volts. And let's set it back to 12. There we go. And let's pull some power out of here. We should only be able to get to about 18 to 20 watts. It did say 20 watts in the tester. So there's 8 watts, 10 watts, 13, 14, 15, 16, 18, 19, 19.7. That's probably about as far as I want to push it. There we go, 20 watts. So yeah, you can actually pull 20 watts out of it. It's a 20-watt quick charge port. Bluetti's documentation says that the USB ports do not function when the battery is removed. So let's remove the battery. Close that up. I'll plug it into a 13.8 volt DC source, similar to as if it's running in a car without the battery. And let's see if the USB ports still work. Alright, got my tester hooked up. Let's plug the cable into the USB-C port, and nothing. So Bluetti's documentation says the batteries do not work without the battery installed. They are in fact correct, at least with the USB-C port. It does nothing when the battery is not installed. Let's do that again, this time with the USB-A port. Get that plugged in. I'm not expecting this to work either. It's probably the same controller for both. And yeah, doesn't even power on. Now, I do understand why they say this. When you're running off 13.8 volt vehicle, you are limited to 10 amps out of the cigarette lighter port. 10 amps out of the cigarette lighter port is about 100 watts. If you were pulling 100 watts out of the USB port that's on the side of the refrigerator, it's got no power left to actually run any of the other electronics in the refrigerator, except just passing all the power through to the USB port. If it were to try to draw more, which it would have to if it was going to run the fridge, it would wind up melting the cigarette lighter port. So it's actually a smarter idea for Bluetti to simply disable the USB-C ports. As you can see here, I've got the USB-C port plugged into my tester, and down here, which it doesn't want to focus on, down here I've actually got the power plug. So it is in fact plugged in, and refusing to run from USB-C, which from a design standpoint, yeah, it makes sense as to why it is they did that. Battery charging rate test. How fast does the multi-cooler charge off of various sources? It, of course, comes with the three methods I specified earlier, the car adapter, the house plug adapter, and solar panels. You can charge it all three ways. I'm going to simulate actually all three of them with my power supply. So what I've got here for my setup, I've got the solar charging cable that comes with it is actually running into this circuit breaker so I can turn the power supply on and off faster, which is then connected to my power supply. I've got a battery in the multi-cooler, and the battery is, as you can see, two dots out of 5. It's somewhere around 30%, so it's not charged at all. So first I've got it set to 12.8 volts. In fact, let's turn it up a little bit to 13.8. But car running. There we go. We got about a running car there. Let's turn this on and see how much it pulls. So we see my current meter here is slowly going up. This is very much not the same MPPT controller that Bluetti uses in its other devices. It's much slower. And it doesn't go as fast. We're going to be only pulling about 5 amps when it gets all the way up to the top. Let's give it a minute and see if it does. And there we go. We've reached the peak of 5.5 amps. I used time compression there because it actually took about a minute to get up to 5.5 amps, and I didn't want you all just to have to sit there and wait and watch it. So 5.5 amps is as much as it's going to pull on a cigarette lighter port. About 70-ish watts, 60, 70 watts, somewhere around there is what that works out to. Let's turn this off. And now we're going to switch it up to 24 volts. That's what the AC adapter that comes with it supplies. There we go, 24 volts. Turn this back on. And you can see it goes up to 4.5 and then drops back down to 0 and then slowly comes back up just like before. Let's give it a minute and see where it stops. And there we go. It stopped at about 4.3 amps, which is actually faster charging than the 12 volt input. 12 volts, I measured 0%, in other words, completely dead battery, to 100% in a little under 12 hours at 12 volts. So if you're in a car and you've got the engine running, it is going to take 12 hours to fully charge from 0 to 100%. And that is assuming that the refrigerator is not running, by the way. The compressor is turned off right now. So it's just charging the battery. It's not doing anything else. And from 24 volts, you can shave that down to about 8 hours, but that's still quite a long charging time. So if you need a faster charge than this, you're going to want the AC180T, which has a much faster battery charger in it to recharge these batteries. One more thing to show you guys here. Of course, solar charging, but there is an issue with my test unit. The issue with my test unit being, for a reason that I do not fully understand, when I set it to 18 volts, which is right around what the solar panel puts out, and I hook it up to the power supply, pulls some current, right here, goes back down to 0, but then it just stays at 0, and it never actually pulls any power. So apparently when I'm simulating solar from my power supply, it does not want to actually charge. I have reported this issue to Bluetti. I am hoping that this is just an issue with the prototype piece of hardware. And by the way, there is a workaround to this that takes too long to do on camera. If I raise the voltage by 1 volt and give it 20 minutes between tests to be able to reset the voltage, you can actually get it to pull power correctly, and which is actually more like what a real solar panel does anyway. Solar panels don't change their voltage that fast, so it just doesn't like being run off the power supply here. So let's take a look at the actual voltage readings, and you can see here that it is quite a bit slower than any of the MPPT controllers that Bluetti ships in their solar generators. So even the controller in the little AC2A is going to be quite a bit faster than what's in here. Next, we're going to test the cooling power of the multi-cooler itself because, after all, it is a refrigerator. Let's make sure it actually keeps the food cold. So how we're going to test this, I have my recording digital multimeter that you guys have seen in other videos. It also has a temperature mode. How that works is it has a little temperature probe here. This little tip on the end here is where it records from. And I'm going to put the temperature probe with a little clamp down in the bottom of the fridge, and I'm going to clamp it down such that the probe is in the up position, like this. Why do you want the probe in the up position? Because if the probe is in the down position and you get condensation, a little droplet of moisture hanging off the end of your probe can actually affect the temperature. So I want to put it in there in the up position, and I'll put it kind of down as deep as I can get it down in the bottom of the fridge. And there we go. This is how I'm going to be set up for all the temperature recordings that you see basically throughout the entire video. Is just like this. One other thing here, I don't have any other food in the container. It's much harder on a refrigerator to keep temperatures stable when it's empty than when it's full. Because when it's full, it's got additional thermal mass that's going to resist temperature change. When it's empty, air doesn't do that great of a job of holding cold. It's really stuff that's solid or liquid that does a better job of holding cold. So I kind of want to put it through the harshest scenario, so let's test it empty. Experimental setup here is the refrigerator is in a temperature-controlled room at 68 degrees Fahrenheit. And yes, 68 degrees Fahrenheit is not very hot for a refrigerator. It's winter. I don't want to spend that much on heating bills. 68. That's what we get. We ran it 3 times, one at 35 Fahrenheit. With eco mode turned on, one at -4, that's as small as it goes, again with eco mode turned on, and one at -4 with eco mode turned off, that's max cool, to see what the eco mode really does there. And each time we started with the battery completely full, and with the food compartment at room temperature, empty as you saw before. So we included that initial cool down in the battery benchmarking. And what did we get as runtime? Well, the maximum runtime, of course, being 35 Fahrenheit EcoCool, 3 days and 4 hours and 26 minutes. That, of course, includes the initial cool down in that timing. So, yeah, over 3 days on a single battery, and that's with no external power connected. So that's actually not bad at all. When you put it in freezer mode, it drops dramatically, kind of as expected, because the difference in temperature between the internal temperature and the external temperature is really what drives the battery. So when you're looking at much cooler temperatures, you're going to get dramatically lower run times, and we are. It's less than half. 1 day, 8 hours. And if I turn it on max cool versus eco cool, what does that do? That takes another 4 hours off of it. But what's the difference between max and eco? We'll take a look at that in a moment. If I look at the log of the temperatures that the refrigerator maintained during the actual cooling process, you can see that it started at about 70 degrees Fahrenheit in the room for the refrigerator mode. And actually, I accidentally forgot to turn on the meter for the first couple of minutes there on the freezer mode. So it's all the way down at 50-something, 58, 59, something around there before I turned the meter on. So sorry about that one. But basically, it drops down, interestingly, below the setting you set it to. Because I have it set to 35, and you can see in both cases it went below what it's set to. So 35 for fridge mode and -4 for freezer mode. It went almost all the way down to -10. All the way down to -10, in fact. And it went almost all the way down to 30 in fridge mode before it stopped there. And then it sort of waves around. It goes up and down, waving around. And that's just the compressor turning on and off. That's completely normal for a refrigerator. And you don't see any temperature that's way out of spec. So it does seem to do a good job of keeping the food cool. So what does max mode do? In simply, it runs more power to the compressor. So the compressor is running in a higher energy mode, which of course causes the battery to go dead faster. What does it do in the use case where the room is nice and cool? Not much. It reduced the runtime by 4 hours, but it didn't really affect the cooling much of all, as you can see. I mean, the graphs aren't perfectly lined up here, but I wouldn't expect them to be. So where do you want max mode? If it's really hot outside, it's 100 degrees outside and you're camping, then the compressor might not even be able to keep up in eco mode. You might have to switch it to max mode. And that's what it's for. But I don't have the ability to test that during winter. And as I said before, we got about 3 days, 4 hours, and 30-something minutes. You can see this E1, that's the error when it ran out of battery. Next, we're going to take a look at the ice maker functions. So we're going to do a few tests at the same time to make things go a little quicker. So first off, the status of the test. I have the multi-cooler here is running off the battery. The battery is basically full because we're not doing a discharge test at the moment. I have it set to refrigerator mode, so 33 degrees is what it's set for, and I have my temperature probe set up. And I currently have nothing. In fact, we're actually going to remove the little scooper from the ice maker here because it's going to get in the way of the camera that I'm going to set up later so you guys can see what's going on. So the ice maker has basically 4 modes of operation that it can work in. It can make small ice or large ice, and it can make ice one time, where when it makes one batch of ice, then it stops. Or it can make ice continuously, where it continues making ice until it runs out of water. That second one is really the one I'm interested in, because the make ice once is just a subset of make ice the first time of continuous. So we're going to measure, first off, how long does it take to make the first batch of ice? Then how long does it take to make each subsequent batch of ice? And we're going to do that in both small mode and large mode. And while it's making ice at the same time, we're going to use a temperature probe here to measure how the temperature in the food compartment is affected. And why do we care about that? This fridge, like most portable fridges, only has one compressor in it, which means that it can only run either the food compartment can be cooled or the ice maker can be cooled, but it cannot do both at the same time. So one or the other, you can't do both. So let's go ahead and put the water in. This can take 1 liter of water. And I have my measuring cup here with 1 liter of room temperature water. It is 38 degrees in here, or 38 degrees, 68 degrees in here. That's not quite that cold. And as you can see, you just sort of pour the water down in the top there. There we go. And by the way, I do recommend, and I did check this before we started recording, there's a drain plug that you saw earlier on the back here. Always make sure your drain plug is closed before you start pouring water into it. Otherwise, you just get water all over your workbench and the floor, and then you got to go grab towels and clean it up. Ask me how I know. Anyway, let's get this started off, and we'll see how long it takes to make ice. And we're going to save the ice from the first attempt to compare it to the ice from the second one. So we're going to make large ice first, and then we're going to make small ice. All right, so we've just completed the large ice run. The ending temperature of the internal cooling food compartment is 52 degrees. And we're going to go over the graph in a minute here to see if that's an issue. The ice just barely fits in the compartment here. It's actually a little bit too big to fit in the compartment. There we go. Got a big compartment full of ice here. Lots of ice. And we're going to take this ice, completely full, and we're going to put it in a Ziploc bag, and I'm going to stick it in my deep freezer. And we will run this test again with it set to small ice. And I'm going to turn the freezer, or excuse me, the internal food compartment, down to the minimum set temperature. So we'll get another run to see how high the temperature raises there, and we'll be able to compare the large ice to the small ice. So how long did it take to make the ice? 24 minutes for the small ice, somewhere around there, and 28 minutes for the large ice. So large ice does take a little bit longer. By the way, my timing does include the defrost cycle and the amount of time it takes for the ice to actually hit the bin. So it's from the time that it starts to the time that it hits the bin is my measurements there. You will notice that there's one case in the large ice where it goes to 50 minutes. In fact, over 50 minutes. What happened there is it didn't actually drop the ice. It did a defrost cycle. For some reason, it got confused and thought the ice dropped, and it made a double thick set of ice, which then, by the way, did drop off properly, so it did actually work. I just wound up with one batch that took twice as long as all the other batches because the ice was twice as thick. Interesting there. So what happened to the temperature of our food compartment while we were making ice? As I said before, there's only one compressor in here, and it can either cool the food compartment or make ice. It can't do both at the same time. So of course the temperature of the food compartment goes up while you're making ice. Now, again, this is an empty food compartment, so this is kind of worst case scenario. And it's a continuous ice session with the maximum amount of water that the unit can take. So again, worst case scenario. So the temperature of the food compartment went up. Is that a problem? How bad is too bad? To answer this, I'm going to defer to U.S. government numbers. This is from the FDA's website. They call the food danger zone anywhere between 40 Fahrenheit and 140 Fahrenheit. And as long as the food stays out of the danger zone for less than 2 hours, the government numbers seem to be fine with that. So what actually happens here? I've taken my graph here and I've added the food danger zone. And it does, of course, enter the danger zone. And the freezer thaw line, that's another one that I've added here. The government doesn't care about that one so much. That's more important if you've got, ice cream in your refrigerator. Products with a lot of fats and oils in them will actually melt. The freeze temperature is actually lower than that of water. So we don't want it to go above, say, 28 degrees Fahrenheit or stuff's going to start thawing. So how long does it stay in these areas, the food danger zone and the thaw zone? So let's take a look at the numbers. We stayed above the thaw line for 20 minutes, which I'm not worried about at all, because if I go to the grocery store and I buy some ice cream, it's probably going to take me longer than 20 minutes to get home. So that's not really a problem at all. Stuff doesn't tend to thaw that fast. For the food danger zone, we have an hour and 20 minutes. That is about 3/4 of the 2 hours that the government numbers say is safe. So it is under the limit for safety there. And in some cases, it may actually take you that long to get the food home if you were to go to a grocery store and buy it. That being said, if you've got really sensitive food, raw fish that you intend to eat raw, or let's say you're making a raw beef dish that you're intending to eat raw, and not a lot of people do that one, but let's say you are, in that case, you probably wouldn't want to use continuous ice mode while that food is in the fridge. And this is worst case because the fridge is empty. So it's got no thermal mass to keep it cool, and I made as much ice as I can. So if you've got sensitive stuff and it's in refrigerator mode, you might want to use single mode and then let it sit for 20 minutes or so before you do another single mode. I've just finished an ice making session here where it ran out of water at the end of the session. And at the very end, you can see it didn't have enough water left to actually clear the ice off of the ice making metal tines here. So we wind up with this frozen snow effect that's sort of stuck on the inside of the ice maker. If you do get to this situation, it does take a bit for the system to clear itself out. You basically have to wait for it to melt, because it's not going to automatically defrost and there's not enough water left in the system for it to do its normal clearing operation. So if you are planning on continuously making ice, add a little bit of water every now and then to avoid this situation. During my testing with the ice maker, I ran into one more thing that should really be called out in the manual, but isn't, so I figure I'll point it out here. This little bar right here. See, it moves up and down with my finger here. You can also see that it can get stuck in the down position. And it can easily be bumped by the ice tray. This little bar here is actually the sensor that's being used to determine whether or not the ice has fallen off the cooling tines and into the ice bucket. So if this little sensor is not in the up position when you start the ice making run, it'll actually get stuck. It'll make the first set of ice, and then it will just beep at you and stop, and it will refuse to eject the ice. And you'll be sitting there confused as to why it is that it's not even trying to eject the ice. It'll refuse to go into the defrost process. It'll get stuck, and it's just all bad. So one thing to definitely be careful of is when you start your ice run, make sure this little sensor is in the up position, not the down position, because you can see it does very easily on mine anyway, get stuck in the down position. So make sure it's up. One more thing I've gotten to happen a few times during my ice making tests is the ice will come off the little ice making tines and then just balance perfectly on top of the sensor that detects whether or not it's dropped, which is a little strange. In all the cases, I've just walked over and bopped it with my hand to knock it into the tray. But it does get stuck sometimes, so something to keep an eye on. Sound level check. How much sound does the multi-cooler make when it's running? Because you're going to have it in your campsite right next to you. First, let's see for a baseline here. We're about 40 dB in here. That's with no sound. Let's put the battery in. Close that up. Make sure that this turns on. And it is set to the minimum temperature of -4 Fahrenheit. Give it a moment for the compressor to kick on. We're at about 43, 44 decibels here. That's with the compressor running, but with the ice maker turned off. 44 decibels. Let's go ahead and kick on the ice maker and see how much noise that makes. So we're at about 58 decibels here with the ice maker running. Let me turn that back off here. So that was 44 decibels and 58 decibels with the ice maker off and on, respectively. Bluetti advertises this as 30 decibels and 45 decibels on their Indiegogo page. Maybe that's true for the production models, but the test model that I have is drastically louder than that. 30 decibels is below, at least in an urban area, that's below a silent room. I've actually never even seen my meter read that low. And since decibels goes up on a exponential scale, getting up to 58 decibels, 58 is pretty noisy. So the readings that they have of 30 dB and 45 dB, those didn't seem right to me when I saw the advertising. And according to my measurements, yeah, I'm not getting anywhere near that. I'm getting about 45 when it's in refrigeration mode, which is actually not bad. That's about the same noise as my home refrigerator. So that wouldn't bother me. But the 58 decibels for the ice maker, that is quite noisy. Will the ice maker mode work when it doesn't have a battery installed? So to try that, pop this open, take the battery out. There we go, it's sort of sticking out the front there. And now let's plug it into my 13.8 volt DC power supply. Turn that on. There we go, we've got power running to it. It has now turned itself on. And it's got, again, no battery. The battery's hanging out the front. In fact, let's make it even more obvious. There we go. We got no battery in it at all. We got a big hole in the front. Let's turn on the ice maker and see what happens. So I'm just going to hit the button up at the top here. Beep. It's not pulling a whole lot of power yet. Oh, there we go. Well, let's leave it alone for a little while and see if we come back later to have some ice. And it appears it's tripping all over the floor. But regardless, it appears that we do actually have ice. So that did actually run without a battery, somewhat to my surprise. It took 23 minutes roughly to make that one batch of ice. It was set to small ice, and best I can tell, it did not go over the 10 amp current limit. that cigarette lighter ports can handle. Most vehicles can do up to 8 amps, and I didn't actually see it go over 8 amps myself. We will have to review the video later just to make sure that it didn't. But yeah, seems to make ice without a battery in it. Next up, let's take a look at some ice. Turn on my scale here. This is the large ice that was made in the multi-cooler itself and then placed into my deep freezer. I have a non-defrosting freezer that I use for food storage. And put it in there overnight to let it stabilize. So this is 10 pieces of ice. We are looking at 46.5 grams for 10 pieces. The ice itself is nice and clear. Looks like it'll make really nice drinks. Same thing here. We're looking now at 10 pieces of small ice that was made from the multi-cooler, and then after the multi-cooler was done with it, I put it into my chest freezer overnight. And I'm picking pieces, kind of average size pieces as best I can. Interestingly, the 10 pieces of small ice is only 1 gram less than the large ice. So there really isn't a lot of difference, really, between the small ice and the large ice. If anything, the sample that I have of the large ice tends to be a little bit clearer than the small ice. I'm not entirely sure actually what the difference is between the two. They both seem to have about the same amount of time to make the ice, and they seem to be about the same size, so not entirely sure there, but I was asked on the forums what the difference between the large ice and the small ice is, so there you have it. Next question I was asked is, how much ice can you make on a single battery? So testing procedure here, I used large ice because, as we saw before, it doesn't seem to make that much difference as to what size. Room temperature 68 degrees. I let the battery cool the food compartment first, down to refrigerator temperatures. And then I put it on continuous ice mode and let it make ice until it ran out. And then as soon as it ran out, I put more water in it, turned it back on, and set it back to continuous ice mode again. And continued that process until the battery went dead. That took about 4 runs of the ice maker. And of course the water was room temperature each time, 68 degrees. So just about 4 batches of ice. So how much ice is that? That's 1 batch. This is 2. And for the next 2, I'm going to have to leave the plastic bag on because otherwise it's not going to fit in the container. That's 3. And that's 4. So on 1 battery, you can get about 7.15 pounds of ice out of the ice maker. So we've run the multi-cooler through pretty much every test I can think of. So what do I like about it and what do I not like about it? What do I like? It does a good job keeping the food cold. I mean, when it comes down to it, it's a refrigerator. That's what a refrigerator is supposed to do. It's supposed to keep the food cold and keep it so that your food doesn't go bad and you don't get sick while you go camping. You don't have to worry about bringing ice. And if you're at a campsite, and you're 2 hours away from town, you don't have to drive back to town to figure out how to get ice. So, I mean, yeah, it definitely does what it's supposed to do. It's simpler to wire up in that it's got the battery inside the refrigerator itself, and you can just connect a solar panel to the side of the refrigerator, assuming your solar controller works. We saw earlier that mine had an issue in the pre-release. I'm assuming that's going to get fixed. But what's not to like about it? The ice maker is a little bit finicky. It gets stuck sometimes, and it is dramatically louder than is being advertised by Bluetti. That being said, if you're out camping, does it matter? I'm not sure that it matters that much that the ice maker is a little finicky if you're sitting right next to it. And I'm not sure that it matters that it's louder unless you're trying to sleep while you're making ice. But I really wouldn't do that with this one anyway, because the ice maker compartment is not cooled. Meaning that if you make ice right before you go to bed, it'll be melted by the time you wake up anyway. So why did you bother to make the ice? So there's that. It is a convenience item, of course. The ice maker both can make, nice mixed drinks in the middle of nowhere. And additionally, another use for it, by the way, since you can actually get, 7.5 pounds of ice before the battery goes dead. If you've got enough solar hooked up to it, you could potentially use this and the ice maker in this to keep another non-electric cooler full of ice. So you could actually probably drive a second cooler off this one. That being said, of course, be careful with the food temperature while the ice maker is in continuous mode. So pluses and minuses. Is it a replacement for a full-size refrigerator for something like a cabin? So let's say you have a cabin. Let's say you have enough space for a full-size house refrigerator. This is not dual zone. So that would be my main reason for saying no to that, is that it does not have both a refrigerator and a freezer built into the same unit. It's single zone. Could you use two of these? You could, absolutely. No reason not to do that. You'd have to consider the size and the pricing. If you do have the space for a full-size refrigerator, that might be the right answer. This is going to be far more efficient, though, being a DC fridge, just running straight off the battery. So does this do what you need? You can decide on that one, but now you have an idea of what it does. As always, I am not paid to make these videos. I make them because they're fun. Bluetti does send me the product ahead of time so that I can actually make the video. And other than that, they have no say over the content. They can't tell me what to do, and if they did, I'd tell them no. Monetization in the channel is turned off, and I have no interest in turning it on. I do not make money on solar generators. I make my money in tech, but it's elsewhere in tech. It's not on solar generators. I don't make any money off YouTube. I do this because it's fun. And as long as I keep having fun making them, and you guys keep having fun watching them, I'll continue to make more videos, and we'll all have fun with this. So have fun.